we're going to kind of pull together all the things we've talked about over the past week. This worksheet kind of does that with one additional element, and we're going to call that scalar multiplication. This is probably one of the easiest concepts with vectors, is to be able to multiply by a scalar. Essentially, if you remember that a vector is a set of directions to go get you from one point to another, typically we say it has magnitude and direction. In other words, if I point in one direction and I go a certain distance, that is essentially what a vector will do. When we multiply by scalars, like what you see in number 1, like negative 3u, let's take each one of these pieces one at a time. The negative makes it an opposite vector. It changes the angle that you're going by 180 degrees. It makes you go just, if you were walking forward, it's like walking backwards. The 3 changes the length that you're walking. In other words, if I'm going to be going u units long, whatever that magnitude is, if it's 3u, I'm going to be going 3 times as long. A scalar, which is what we call this 3 out front, the negative 3, is going to magnify my coordinates by 3. So literally, this is exactly like the distributive property. When you see something like this, it's like saying negative 3 times my 2 original components to give me negative 60 and 63. It changes the signs as well as it magnifies them by the factor of 3. If we look at number 2, this was the same kind of idea, except it makes us do a little bit more. It makes us find the actual vector from 2 points first. If you remember from how we found the vector, we would say the terminal point minus the, give me a second, the terminal point minus the initial points. We're going to say this point minus this point, and that would give us the negative 1, 13. Then it says to multiply that value by 8, so 8 times PQ, so 8 times PQ distributed, 8 times negative 1 is negative 8, and 8 times 13 is 104. Nothing fancy, nothing special there. And really, for the rest of this worksheet, it's essentially like what we've done in class. It pulls together different elements in one way or another. And you can see here in 3, I've given you vectors, and they want you to add them together. This is what we did yesterday. Remember, when you add vectors together, you add their components, right? X's get combined, right? So U is 3, 3, and then V is 11, 8. If I set it up like this, kind of like an algebraic expression, I'm going to be adding the X coordinates together to get 14, and the Y coordinates together to get 11. If I had had some scale factors involved, like number 5 or 6, then we would set that up exactly as before, but I've got to do a little bit of distribution first. Remember, order of operations still holds true here. We're going to multiply here first before we do the subtraction. So we multiply through each piece. So 4 times this vector gives me 48, 8. And then 6 times this vector is going to give me 12 and 24. Now, I want to make a point to talk about this thing, the negative sign. I try to make things as simple as possible and try to avoid as much careless mistakes as I possibly can. One of the issues is, there's 2 ways to look at this one. I can distribute by 6 and then subtract the 2 vectors, just like I did on the page. I can also multiply by negative 6, like here, and then get negative values, but I have to remember to change this sign to addition. If that's what you're used to and that's how you've always done this, then that's fantastic. That's exactly what you should do. But sometimes we tend to forget we have a negative sign and we do the negative 6 and then we subtract again. That would be a double negative here, and that would turn out to give me the wrong numbers at the bottom. It would be a careless mistake that would cost you a lot of points. Whichever way you tend to go, make sure that you do it and become comfortable and confident in that's the right way. Okay, if I look at number 6, kind of in the same light, this one adds together kind of everything we've talked about so far on this page. It makes me find the vector from the 2 points by subtracting. So I do that real quick. That's kind of step 1. I'm going to put those vectors into this form so that I can kind of do that outright. I like to write it down. That gives me a way to see the steps. I don't make as many careless mistakes. And so we're going to say the 4 times the 6 and the 2 to get this value. And then I'm going to take these 2. I'm going to add them together to get my result. Okay. The next part we're going to talk about, 7 and 8. This is a little bit from yesterday. We talked about a unit vector in the direction of another vector. Right? First of all, they don't give me the vector AB. I have to find it, so we're going to do the subtraction. Negative 6 minus 4 gives me negative 10. 10 minus 0 is also 10. Step 1 in this problem will be to get the vector. Step 2, whenever I find a unit vector, I have to find the magnitude of the given one. So we do that. Negative 10 squared plus 10 squared gives me the square root of 200, and that would be 100 times 2. So we take the square root of each of these numbers. It's nice that 100 does have a square root, 2 doesn't, not a whole number anyway. And so we end up with 10 square roots of 2. Step 3 in this problem would be to take my magnitude, and this is how you find that unit vector in the direction of whatever you start off with, is you divide the original components, 10, negative 10, and 10, by its own magnitude. And then at that point, I've got a little bit of simplifying to do. We divide out the 10s. That leaves me with negative 1 over the square root of 2 and 1 over the square root of 2. On a multiple choice test, I'm not going to be able to see radicals in the denominator. If this was a regular test and short answer, I would be okay with an answer like this. But multiple choice, which that happens from time to time, especially on benchmarks, you're going to need to rationalize. We multiply the top and the bottom here on both fractions by the square root of 2, and that gives us this value, which is actually something from the unit circle, which we called the unit circle because it has a magnitude or a radius of 1, which is all connected. Okay, number 8, just to kind of refresh your memory on what the word opposite means when we're talking about vectors. I found the vector, just PQ, and it was here. An opposite vector literally means the negative of that vector or the opposite signs. Be careful, I didn't say negative, right? We multiply by negative 1, and it changes the signs of whatever originally was there. So if one of these had been negative, then that would it would change them into a positive value. In this case, they were both positive, so we end up getting negative 6, negative 5. On the second page, I wanted to kind of start off talking about magnitude and direction. Now, we had formulas for magnitude and direction, which we are going to kind of you're going to use here. If we look at number 11, I want to talk about this one particularly because it has an angle measure that we have to be careful about. Now, magnitude is just the Pythagorean theorem, right? I've got x and y here, so we wanted to find the negative 5u of that. So we ended up doing this, multiplying. So we ended up getting negative 60 and negative 80. So this is the vector I'm going to be working with. This happens to be in the third quadrant, right? And so I'm going to come over here. I'm going to plug that in, negative 60 squared plus negative 80 squared. If I square root that, I'm going to get 100. Okay, so the magnitude is 100. That's your first answer. The other answer would be whatever theta is. When we plug this in, I'm going to give you tangent inverse of negative 80 over negative 60. Yes, that does become positive. However, that does not change the fact that your x-coordinate here is negative, right? 53.13 degrees is really in the first quadrant. So I can clearly see that that vector is not in the same location. But that's because we needed to add 180 anytime you have an x-coordinate that's negative. And that's something you're going to have to put in your brain, write it down, memorize it, put it at the top of your test when you're taking it, just to remind yourself to do that. That is one of the most commonly missed parts of this next test or quiz. Okay, so 233.13 is the final correct direction or angle measure of my vector. Okay, all the rest of these are good practice. I'm not going to give you the answers now. The answers will be posted a little bit later. Give this a good shot. Practice these up. This is kind of the culmination of what we've done this week. We do want to talk about one more thing for vectors in terms of graph. Now, I don't have a graph paper on this page, but if you're doing this, I highly recommend you use graph paper. I'm just going to kind of estimate this value, so you're going to see it here. I'm going to graph the first vector, negative 7, 1, right? So I'm just going to kind of roughly estimate this. So I'm going to go over negative 7 and up 1. So we're going to end up here. We're going to start at the origin to begin with. I always put, really what we're doing here is we're doing m plus n, because we want the resultant of this vector. So we're going to be combining the vectors, and by default, we're adding them together. They should have written that down. I don't know why they didn't. The next part, I'm going to add vector n to this, right? So what's really going to happen is I'm going to take this vector, but I'm going to start counting at the end of the first vector. So I'm going to start as if this is my first place, right? So if I were to do this, I'm going to take that, I'm going to go this direction 12 units. Well, if I'm starting at -7 and I go 12, this way I'm going to end up at 5 over here. All right, so I'm going to put that down as a +5. And then I'm going to go down, we'll go way down here out to the bottom. That's going to be down to -16. I'm exaggerating a little bit, so it's not really drawn to scale. So we're going to go over here 5, and we're going to go down 16. And so we end up drawing a vector that looks something like this. Okay, and so that red vector is what we would consider our secondary vector, right? The answer to the question, or what we call the resultant, is if I start at the very beginning and I go to the very end, this is our resultant vector, right? So this is what we really end up with. This is my drawing. This is my triangle method. I end up drawing a triangle by combining the two vectors. Now, ultimately, it says for me to find the magnitude of direction. I'm going to be honest, I'm not really going to use the picture. The algebra here is so much safer to use. So we're going to draw this out. -7, 1 plus 12, 6, -16. If I were to add these together, we're going to -7 plus 12 is going to be 5. And then +1 minus 16 is going to be -15. I'm going to find the magnitude for this particular situation, which is going to be the square root of 5 squared plus -15 squared. That's going to turn out to be 15.81 approximately. And then theta is going to be equal to tangent inverse of -15 over 5. This is actually going to give me a -71.57 if we round to two places. This answer is perfectly correct. A lot of times you won't see that written down in a multiple choice question because they'll only give you positive answers. So what we do, it's in the fourth quadrant. You can see the angle I'm looking at is right here. That does seem to be approximately, it's between 0 and 90, -90, and it's going to be somewhere closer to 90, right? Because it's closer to the vertical down axis. So I'm going to add 360 degrees to get this to be positive. That's going to turn out to give me 288.43 degrees. So I would accept either this one or this one on a free response question. But if it's multiple choice, be prepared to be able to add 360 to it. Right? I want to make sure to point out that I did not add 180 because my x-coordinate was positive here. So the answer I get out of tangent inverse is a valid answer, right? But if I don't see it in my answer choices, I can always add that 360 to it to try to see if they've only given me positive ones. If I'd had a negative answer here, negative coordinate for x, that's when you add the 180. That is not what we did here. Take your time, go through these, make sure you can understand them. These are the basics for computations with vectors. We're going to start the harder parts next week. So if you got these down, it's going to make that part just a little bit easier. Have a great weekend. If you have any questions, please let me know.